All right. Now we are going to do permutations, combinations, and the multiplication principle for counting. The multiplication principle of counting, that's also called the fundamental counting principle, says that if I can do things in 3 different ways, or 3 different things, I take the number of ways of the first, the number of ways I can do the second, times the number of ways I can do the third, and I just multiply all those together to get my total number of ways. They're going to mess these all together. First one is actually going to be our fundamental, our multiplication principle for counting. Serial numbers for a product are to be made up of using 2 letters followed by 2 numbers. If the letters are to be taken from the first 7 letters of the alphabet with no repeats, and the numbers are taken from the digits 0 through 9 with repeats, how many serial numbers can be generated? So the fundamental counting principle just says if I take the number of ways of each of those possibilities times each other, I'm going to get the total number of ways I can get my combination. So my first one, I'm going to use a letter. I'm going to use one of the first 7 letters of the alphabet, so that means I have 7 choices there, right? My second one, I'm going to use the first 7 letters of the alphabet, but I can't repeat what I used for the first one, so that means I only have 6 choices of what I could use for that one. Because I can't repeat if I already used the first one, now I only have 6 left over, right? On my third one, I'm going to use the numbers taken from 0 through 9, which means I have 10 possible choices. So I have a 10 there. Now we can repeat on our numbers, so again we're using 0 through 9. I have 10 choices here. So in order to find my total possibilities, I'm going to take my 7 times my 6 times my 10 times my 10. 4,200. Now they're going to use that fundamental counting principle with combinations and permutations by figuring out the answers and multiplying the 3 or how many of our things together that I'm going to do. I have 3 research departments have 10, 8, and 7 members respectively. Each department is to select a delegate and an alternate to represent the department at the conference. In how many ways can this be done? So, first thing I have to decide, am I doing a combination or a permutation? Combination, the order does not matter. Permutation, the order does matter.
Combination.
Try the other one. Permutation. Because it's different if I have who's the delegate and who's the alternate. Right? If I switch those around, that would be a different way. So it's a permutation. So we're doing permutations on this one because the order does make a difference. So we have 3 departments. The first department has 10 people. I am going to choose 2 of them, 1 delegate and 1 alternate, right? Then I'm going to do the next department. It has 8 people. Again, I'm going to pick 2 of them, 1 delegate, 1 alternate. Then I am going to have my next one, which is 7. Again, I'm going to choose 2 of them. For fun, instead of doing the long way, we're going to use our calculators because that's why we're learning how to use our calculator. So, we got to calculate a permutation of 10 things taken 2 at a time. So we're going to put in the 10, hit the math button, number 2 for permutation, and then put in the number 2 for 2 at a time. What do we get for our answer if we do that? I worked it out the long way on my paper, but we'll use our calculator. 90. Getting 90 then? Yep. And number 2. And then we're going to put a 2 and enter. There's your 9. Okay, now we're going to do the second one. The second one, we're doing a permutation of 8 total people. We're going to take 2 out of that 8. 56. The third one, we're going to have 7 people, and again, we're taking 2. $42. So now, based on our fundamental counting principle, or the multiplication principle for counting, I'm going to take my 90 times my 56 times my 42. I get
Was that 50? Or
56, 90, 56, and 42. 211,680. So I have 211,680 ways of choosing those groups of people. Number 15. A catering service offers 5 appetizers, 11 main courses, and 3 desserts. A banquet chairperson is to select 3 appetizers, 8 main courses, and 2 desserts in a banquet. How many ways can this be done? So if I'm picking out appetizers, does it matter if I take my fried pickle before my French fries before my onion rings? It's the same group, right? So I am going to do a combination instead of a permutation this time. The order doesn't matter of my 3 appetizers. It's the same group of 3. Doesn't matter which order they're in. So we're going to do combinations. We had 5 appetizers to choose from. We are going to select 3. For our main courses, we had 11 to choose from. We are going to select 8. And for our desserts, we had 3 to choose from. We're going to select 2. And again, unless you really wanted to work it out the long way, we'll just use our calculator. Same thing as when you did permutations, only now we're going to do choice number 3 to do a combination. So we're going to start by putting in the 5. Hit the math button. Do the probability. Choice number 3 for combinations, and then 3. And what do we get there for the first number? 10. On the second one, we're going to do a combination of 11 things taken 8 at a time. 165. And 3 things taken 2 at a time, we get 3. And then for our fundamental counting principle, we're going to take the 10 times the 165 times the 3 to get our total number of ways.
4,950.
4,950. All right.